Okay, today we're going to be looking at problems involving the intersections of lines and circles. So previously we've looked at problems where you've maybe had a curve and a line and they've intersected, and you would take the line y equals ax squared plus bx plus c, and the curve, and then the straight line would be y equals mx plus c, and you solve them using simultaneous equations. And then if you get a equation in the form of ax squared plus bx plus c equals 0, the a, I'm going to change the name of this to I'm going to call it big A, big B and big C, because these A, B's and C's will be different. And I'm going to call that K. When you do the simultaneous equation, you then get an equation in the form of this, and then if we use b squared minus 4ac, we can learn information about the curve. And we had the situation where if b minus 4ac was greater than 0, then we had two distinct roots, and so this was two distinct points of intersection, like what we've got here. If it was equal to 0, we had two equal roots, so one point of intersection. So that would have looked, if that's our curve and our line kind of just touching it gently there. And if it was less than 0, we'd have no real roots. So no points of intersection. So that would be like that. Now we can do the same with circles. So we can have our circle, and we could have a line that cuts through it, and we can solve it in the same way. We can have our equation for our circle, and we can substitute either y or x. So if we had our equation for circle, we could take the equation for the line and substitute in for y or x, and use the same b squared minus 4ac to tell us a bit about the roots. So you could have that situation, or you could have where the line is tangential to the circle, or we could have the situation we've got our circle and the line doesn't touch it at all. So let's look at an example. So we've got line x equals 3y plus 10, and it intersects the circle x squared plus y squared equals 20 at points A and B. So firstly, we want to find the coordinates of A and B. So we've got x squared plus y squared equals 20, and we're going to take x here and substitute it in for here. So that would be 3y plus 10 squared plus y squared equals 20. Now we're going to expand that out. So let's just do that over here, just to keep track of everything. So we'll have 9y squared plus 30y and another 31, so it's going to become 60y plus 100 and now we'll substitute that back into here, so that will give us a 10y squared, because 9 add 1 is 10, plus 60y plus, now the 100's there, but this 20 is going to come over and that's going to make 80 equals 0. Now we're going to divide through by 10, so that's going to give us y squared plus 6y plus 8 equals 0, and now factorising that is going to give us plus 2 y plus 4, so therefore y must be equal to minus 2, or y equals minus 4. Now if we slot this back in, we're going to have when y equals minus 2, x must be 4, and when y equals minus 4, x must be minus 2. So the points A and B are minus 2, 4, or minus 4. Let's check that minus 2, y is minus 2, so that is plus 4. And the other one is minus 2, minus 4. Got that right, minus 2 and this is, oh, I've put them the wrong way around, that's why I've got them muddled up. So here we've got 4 minus 2, and here we have minus 2, 4, because I've written the y's in the wrong side. There we go. Now, so we've got our coordinates A and B. So we're going to, now we want to find the equation of the perpendicular bisector of AB and show it passes through the centre of the circle. So let's just think about what that means. So there's our circle, and so we've got our line AB through it. Our perpendicular bisector, so there's A, there's B, would be halfway through it. So it's going to be a midway point, and it's at right angles. So let's firstly find the gradient of AB. So that's going to be minus 2 that's minus 4. Minus 2 minus 4 over 4 minus 2. So that will be equal to a third. So therefore the gradient of the perpendicular bisector. So if we've got the gradient of AB times the gradient of the, I was going to write that for the perpendicular bisector, it must be -1. So this is a third, and so M, so it would be kind of perpendicular down there, must equal -1. So the gradient of that must be equal to -3. So now we need the midpoint of AB. Must be, so for the x coordinates we're going to have -2 plus 4 over 2, and we're going to have -4 plus -2 over 2, and that will give us 1 minus 3. So the midpoint is one of the points of the perpendicular bisector. So we're going to use our general equation for a straight line. So y minus y1 equals mx minus x1. So therefore we've got y minus -3 equals to m, which is going to be -3, x minus 1. So if we work all that out, we will get y equals -3x. Now, what is the centre of our circle? The centre of our circle is 0, 0. So if we look here, if x equals 0, y must be 0 on our line. Therefore, y equals -3x passes through the centre. I'm running out of space here. We want to find one other thing out with this. So if the perpendicular bisector of AB intersects at points P and Q, find the exact coordinates of P and Q. So we've got, for our circle, we've got x squared plus y squared equals 20, and our bisector is y equals 3 minus 3x. So we are going to substitute -3x for y. So we'll have x squared plus -3x squared equals 20. So that's going to give us 9x squared plus x squared, which will give us 10x squared altogether equals 20. So x squared must be 2, so x must be plus or minus the square root of 2. So when x equals minus the square root of 2, y must be equal to 3 square root of the next again. Oh dear. 2. And when x equals plus the square root of 2, y must be equal to minus 3 square root 2. So the P and Q are minus square root 2, 3 square root 2, and square root of 2 minus 3 square root of 2. So let's look at one other problem. So we've got the line y equals x minus 13, and we want to show it is a tangent of the circle x squared plus y squared minus 8x plus 6y plus 7 equals 0. So we're going to begin by substituting x minus 13 for y. Now the substitution you make will be determined by what's going to make the calculations the simplest. So x squared plus x minus 13 squared minus 8x plus 6 x minus 13 plus 7 equals 0. So we're going to take, I'm going to just break out the brackets here for this one. So we'll have x squared, and then we will have 13 minus 13x minus 13x will make give us minus 26x, then plus 13 squared is 169. So let's put this in here. So we're going to have it's going to be 2x squared minus 26x plus 169 minus 8x plus 6x, break out this bracket here, and that's going to be minus 78 plus 7 equals 0. Now we're going to gather the rest of our terms together, so we will have an 2x squared. Now we've got minus 26 minus 8 and a plus 6. So that's going to give us let's see, oh, but minus 26 minus 8 and then plus 6 is going to be minus 28x, and then for our final term 169 plus 7 minus 78 is going to be plus 98 equals 0. Now we can divide through by 2. It's going to be x minus 14x plus 49 equals 0. Now we are going to factorize this. X, so that's going to be minus 7 minus 7, x equals 7 in both cases. So there's only the equation has one distinct root. therefore the line is tangent to the circle. Now, you could use the b squared minus 4ac here, and it would show the same thing. It's up to you, whichever's going to be easiest. This is quite an easy one to factorise, but if it was more tricky to factorise, you could use the determinant to work that out. So I hope that helps.